So hello friends, today we discuss about the Henderson's equations. Actually these equations are useful in the calculation of pH of buffer solutions. Okay. Already we know the pH formulas for different acids and bases and neutral solutions. But these equations are useful in the calculation of pH of buffer solutions. So first we see just what is this useful means they are buffer solution. Henderson's equations are used in the pH calculation. The pH calculation of buffer solutions. Okay, acidic buffer and base buffer. Now we derive it for acidic buffer solution. What is the Henderson's equation? So what is for acidic buffer solution? So for acidic buffer solution, we know acidic buffer contains a weak acid and it's a salt with a strong base. It's a salt with a strong base. Acidic buffer contains weak acid and it's a salt with a strong base. Okay. So any acidic buffer contains weak acid and its salt. It's a salt with a strong base. Okay, so here important, just we are taking a weak acid like HA. Okay, we are taking a general weak acid as HA, and already we know it's a dissociation is into H plus and A minus. So actually this A minus anion is also present in salts. Okay. So what is the acid dissociation constant for it? So we know that dissociation constant, that is a product concentration by reactant concentration, HA. So actually if you want to calculate the pH, we have to know the H plus. So convert it into H plus, very simple. H plus is becomes what? Ka into HA. H plus equals S by A minus. Okay. Okay, this is H plus. So now already we know the general formula for pH. What is the general formula for pH? We know equal pH is equal to minus log H plus. So on substituting the values, what is in the place of H plus, we have this total value, that is HA means weak acid concentration. So actually here the A minus concentration is important. So actually here the A minus is obtained from weak acid, H plus and A minus. So here important, acid buffer is also a mixture of weak acid and it's a salt with a strong base. So actually strong base to form this a salt low, compulsory A minus will be there because అదే వీక్ యాసిడ్ తో ఫామ్ అవుతుంది కాబట్టి సో దాంట్లో కూడా A minus ion will be present. Okay. So on applying the logarithm, so we are taking the minus, so make it log A into B. So we can say log A plus log B. This is log A plus log B. In the place of B we are taking HA, weak acid concentration, by A minus concentration. So now take the minus inside. So minus log Ka minus log HA concentration by A minus concentration. Okay. So this again we can modify it. We know that what is the minus log K? We know that P power K, this is nothing but formula of PK. PK is equal minus log K. And by making it as a plus, we know that logarithm changes so reciprocal. It can be written as A minus concentration by HA concentration. So this is the Henderson's equation to calculate the pH of acidic buffer. So what is the final equation actually useful in the problems is the pH equals pKa plus log. So A minus, the concentration of A minus we are taking directly the concentration of the salt. HA means nothing but we know weak acid. So weak acid concentration actually A minus. So in the derivation, A minus obtained from where we obtained this A minus from weak acid. But in the place of A minus concentration we written directly the concentration of salt. Because the weak acid నుంచి వచ్చే A minus ion concentration is very less. Okay, because the A minus concentration obtained from weak acid. So weak acid అంటే మనకి we know that degree of dissociation is very less. So degree of dissociation very less కాబట్టి so A minus concentration will be very less in terms of acid. యాసిడ్ నుంచి వచ్చే A minus concentration very less ఉంటుంది. అది A minus concentration in salt. ఇది A minus మళ్ళీ సాల్ట్లో కూడా ఉంటుంది కదా, బికాజ్ సాల్ట్ ఫామ్ అయ్యేది కూడా దేంతో ఇదే వీక్ యాసిడ్తో ఫామ్ అవుతుంది కాబట్టి సాల్ట్లో కూడా A minus అయాన్ ఉంటుంది. సో A minus concentration is considerable in salt. That's why we are taking in the place of A directly salt concentration. Okay, so this is known as Henderson's equation for the calculation of acidic buffer solutions. So now if you see, if log in the log value you have, if salt concentration, the concentration of salt is equal to weak acid's concentration. Already in the applications in the last session we said that if the milli equivalence of salt is equal to the milli equivalence of acid, that works as a good buffer solution. So how it is means, if salt concentration is equal to acidic concentration, so what will be its pH? So pH equal to pKa plus log. So both concentration equal means they will cancel. Finally we will get log 1. Log 1 value we know it is 0. So pH equal pK means, so pH equal pK is a condition. The condition for a good buffer. So this is also a condition. Okay, actually it is obtained from this only. So this is also treated as a condition for a good buffer solution. Okay, so now we see the derivation of Henderson's equation for calculation of pH for basic buffer solution. So for basic buffer solution we know that any basic buffer contains a weak base. Any basic buffer contains weak base with its salt formed by it with a strong acid. So any basic buffer contains weak base plus its salt with a strong acid. Okay, So here we are taking as a weak base. Generally we know that weak base we are taking in terms of BOH. So its dissociation, so B plus OH minus, and the base dissociation constant Kb can be written as the product concentration by reactants. In the reactant we have the weak base. Okay, so to know the pOH, actually we have to calculate the pH, but we know that for bases generally we calculate pOH, then we convert into pH. So now we have to know OH minus concentration for it. So OH minus concentration is Kb into BOH, weak base concentration, by B plus. Actually B plus here obtained from base. So this B plus ion is also present in its salt. So salt form cheyalante already we said it's a salt with a strong acid. Strong acid to form this salt lo compulsory B plus ion will be there. So after getting OH minus, we know that what is the formula of pOH. pOH is equal to minus log OH minus concentration. So therefore the pOH is equal to, so minus log Kb BOH concentration by B plus concentration. So on applying the logarithm perfectly, so the pOH equal to, so we know that log A into B. So log A into B can be written as a log A plus log B. So become minus log Kb and minus log weak base concentration by B plus ion. So in the place of minus log Kb we can write, so what we can write in the place of minus log Kb. So minus log Kb nothing but Pkb. So Pkb, so it just make it plus, then it becomes a reciprocal log of B plus the log of BOH concentration. So this is the pOH formula for basic buffer. So here important, in the place of B plus concentration, it is important point. In the place of B plus concentration we can write the concentration of the salt, because so ఈ ఫార్ములాలో మనకి B plus from where we obtain అంటే same from the weak base. ఎట్లయితే మనం యాసిడిక్ బఫర్లో A minus we obtained from weak acid, so అదే మోడల్ ఇక్కడ similarly we got this B plus from weak base, but the B plus concentration obtained from the weak base is very less. B plus concentration obtained from weak base is very less, because weak base nothing but dissociation is very less percentage. Okay, so but so we are taking this B plus, nothing but the concentration of salt. Okay, so because the salt concentration means nothing but it is also having B plus ion also in it, because the salt is formed from its base, that weak base. So in the place of B plus we can write the concentration of salt by weak base. Okay. So this is known as a Henderson's equation for the calculation of pOH of buffer solutions. So actually we want to calculate for pH. Simply we know the formula pH plus pOH equals 14. Already we know this formula. It's a basic formula in pH. So therefore, what is the pH of this basic buffer solutions? So that is equal to 14 minus pKb minus log salt concentration by base concentration. So again, if you see the pOH equation, if again the salt concentration is equal to weak base concentration, if you apply on the pOH equation, so it's a pKb plus log salt by base. Log salt by base means it comes to 1. So we know that log 1 equals 0. Again pOH becomes a pKb. So this is also condition for a good basic buffer. Okay. So just like in acidic buffer solution, pH equals pKa. So in the same way, in the basic buffer, if pOH equal pKb, they works as good buffer solutions. Means these two are condition. They two treated as a conditions for a good buffer solution. Okay, so when it is possible, same, the condition is salt concentration equal to base concentration. So here we have to remember two main points. So we take it as a note. So actually in these derivations, in acidic buffer solution, basic buffer solution, pH calculation, Henderson equations derivation, so we replaced the anion concentration of in acidic buffer, cation concentration in basic buffer by their salt concentrations. So why? Because already we said, because the weak acids, weak bases concentration, nothing but their dissociation percentage is very less. Okay, we write it as a point now. So the concentration of anion, that is A minus, actually we took the concentration of anion and acidic buffers is replaced by salt concentration. So why it is? Because the concentration of anion so obtained from weak acid is very less. Okay, so the concentration of anion A minus in acidic buffer derivation was replaced by salt concentration because the A minus obtained from weak acid is very less. That A minus is a considerable concentration is present in salt only. Okay, and similarly we can write same, the concentration of cation. So where we obtain the concentration of B plus in a basic buffer. In a basic buffer solution, was replaced by salt concentration. Again same, replaced by salt concentration. Why? Because the B plus concentration obtained, the B plus concentration obtained from weak base is very less. So whereas this B plus concentration is considerable in salt. Okay. Next, one more important point. So here one more important point is the pH value of acidic buffers or basic buffers does not affected by the dilution. Means normal, for normal solution we know that change on dilution pH value changes for acids or bases. For acids pH value increases, for bases pH value decreases. Okay, so whereas normal, for normal solutions, whereas for normal solutions for normal acidic solutions on dilution pH value increases, means acidity decreases. For bases on dilution pH value decreases, means nothing but their pH also, their basic strength also decreases. But on dilution there is no effect on the pH value of buffer solution, because here we are calculating in terms of ratio. So means the pH of buffers mainly depends on the ratio of concentrations of salts and acids in acid solution, salts and base concentration ratio in basic buffer solutions. So therefore the pH values are not affected by. So here we can write the important point that the pH of buffer solution so is not at all affected by dilution. So what is the main reason for it? Means so it is just because ratio under the logarithmic so ratio under the logarithmic terms is unchanged. Okay, because in the logarithm terms we are calculating the ratio of the two concentrations, so there is no change in the pH of buffer solutions even on dilution. So these are very important equations. I have to remember the derivation and final equation. So we do many calculations on this in next classes. Okay.